Some key points again. Points of discontinuity. We have to be really careful about points of discontinuity when cursing using calculus. So the points of discontinuity can be vertical asymptotes, okay, so where you divide by 0. Could also be where we have holes in the graph, okay, where they cancel out, and where we have breaks in the graph. Okay, those are points of discontinuity we have to be careful of. Okay, so there are more things, but those are kind of something I want to kind of highlight at the beginning here. So let's take a look at horizontal and slant asymptotes again. Horizontal and slant asymptotes are essentially endpoint behavior. They're what's happening as we let x get really, really big. So they're endpoint behavior. We're only going to look at the slant asymptotes, like linear asymptotes, like mx plus b, but in fairness, we can have quadratic asymptotes, cubic asymptotes. Okay, we can have any degree of asymptotes depending on how much bigger the numerator is compared to the denominator. So for example, if you had an x cubed over x, we would have a difference of x squared, and that would mean that you would have a quadratic asymptote. Now that's not the case here because we have a squared over linear, so the difference is 1, so we should have a linear slant asymptote, okay, because when we divide this we should end up with a linear quotient. Okay, so let's look at that first. We want the slant. Let's do the zeros first. The zeros are the easiest. Zeros are going to be at 0. Okay, we have a vertical asymptote at -1. Okay, and the slant asymptote we're going to find from division. So I'm going to do my division. Okay, so I'm going to do my division here. X plus 1 into x squared. We have x squared plus x, negative x, minus 1. So that's going to be actually plus 1. So we're going to have a remainder of plus 1. Okay, so the remainder is really not that significant, although we can use it. But the slant asymptote is going to be really important. So y equals x minus 1. So we're going to have a linear asymptote, a slope of 1. That's going to look like that. We have our vertical asymptote, okay, at x equals -1, maybe somewhere like that. Okay, and we have a coordinate at 0, 0. Okay, so we have to start having an idea what this looks like. The graph's probably going to look like this. Okay, something in those quadrants there. In fact, the positive remainder actually tells us that they're in these quadrants, this positive diagonal, whereas the negative remainder tells us it's in this negative diagonal, would be going across like that. Okay, so this is not that important because we can figure that out anyways because of that coordinate, but it's just another double check. Okay, so we've got all those parts so far. Now comes the calculus part of this. We want to know where the min and max is. Okay, so we're not going to do our second derivative here because we're not going to look for an inflection point, but we want definitely the min and max. So I need to differentiate. F prime x is going to be 2x, x plus 1 minus x squared times the derivative denominator is 1 over x plus 1 squared. Okay, simplifying this, 2x squared minus x squared is x squared plus 2x all over x plus 1 squared. Okay, so I have a non-differentiable point at -1. When I solve this equal to 0, I get x equals 0 and -2. Okay, so we have a minimum at -0. Okay, we're going to have a 0 slope there, and at -2, okay, we have a 0 slope as well. Okay, so then we're going to have our, looks like our maximum is going to be somewhere in there. I should really figure out my y coordinates because those are nice, easy points to work out. So at x equals -2, y equals, when I plug it into the original f of x, 4 over -1, so -4. So my coordinate's going to be at -2, -4, somewhere around here. Okay, so there's my max. There's my min. I should test slopes to double check this. Okay, so that's a non-differentiable point, so I have to be careful of that. I have to make sure that's a point that I'm considering. Okay, f prime at -3. If I plug -3 into there, it's going to be positive. Okay, so I know it's going up, across. Let's go f prime at -1.5. That's going to be negative, so I know it's going down in here. F prime at 0.5, -0.5. It's going to be negative when I plug it into here. Okay, so it's going to be going down through there. Okay, it's going to have 0 slope through here. And then f prime at 1 is going to be positive. So it's going to go up like this. Okay, so we kind of knew what this graph looked like. It's going to go up like that. There's my max point at x equals 2. Sorry, -2. Here's my minimum point at 0. It's going to follow my asymptotes like that. Okay,